All right, good morning, everybody. Welcome to Math Lesson 78. Some new stuff to cover today and lots of it. Get ready for exponents and square roots. So, little bit of review. If you remember, to show repeated addition, we use multiplication. Instead of having to go 5 plus 5 plus 5, we can just go 5 times 3 instead of adding 5 3 times. To show repeated multiplication, we use what's called exponents. If you wanted to go 5 times 5 times 5, you could write it with a 5 and a little 3 in the corner. 5 to the third power is how that would be pronounced. The 5 is the base, the number you are repeatedly multiplying. The little 3 up in the corner is called the exponent. That tells you how many times you're going to multiply the base number. 5 to the third power means I'm going to multiply 3 5s together. Do not make the mistake that a lot of fifth graders before you previously have. Do not multiply the base times the exponent. 5 to the third power means 5 times 5 times 5, which equals 125. It does not mean 5 times 3, which would only equal 15. So, a few little examples with exponents. If you put a 2 in the corner, this would be pronounced 3 squared, or 3 to the second power. The reason why they consider it 3 squared, if I wrote out 3 times 3, it actually does make a square, doesn't it? 3 to the third power, anytime something is the third power, it could also be called cubed. This would be 3 cubed. Because if you lay it out like that, it actually does turn into a cube, doesn't it? The rest are just basically pronounced the same way. This would be 3 to the fourth power, meaning 3 times 3 times 3 times 3. Or this would be 3 to the fifth power, 3 times 3 times 3 times 3 times 3. Again, the base is the number you are multiplying. The exponent is how many times you are multiplying it. So you might run into some questions from here on out like this. Write 5 to the fourth power as a whole number. So remember, the base means the number we are multiplying. The exponent is how many we are multiplying. In this case, we're going to need 4 of them, aren't we? So I'm going to go 5 times 5 times 5 times 5. 5 to the fourth power means we are multiplying 5 4 times, right? 5 times 5 times 5 times 5. So remember, when you multiply, you can only multiply 2 numbers together. So I set it up like this, but I'm going to have to do it step by step. 5 times 5 is 25, right? So then I go and I take that 25 and I multiply it by the next number. 25 times 5 gives you 125. I'm going to then take that answer and multiply it by my last 5. 125 times 5 equals 625. Maybe you would need to set that one up on a scratch piece of paper to make sure, but trust me, it does equal 625. So 5 to the fourth power does not equal 20. It equals 625 because I'm multiplying 5 4 times. Let's try this one. Write 2 to the fifth power as a whole number. So 2 is the number I'm multiplying. I have an exponent of 5, so I'm going to need 5 2's multiplied together. 2 times 2 times 2 times 2. So put in all your multiplying and get ready to multiply. Remember, you can only multiply two numbers together. So I start off 2 times 2. Hey, that's 4. And then I'm going to multiply that product by the next number. 4 times 2, that's going to give me 8. Then I take that product, I multiply it by the next number. 8 times 2, hey, that's going to give me 16. And lastly, I'm going to go 16 times 2, and that's going to equal 32. So 2 to the 5th power really equals 32. The base is the number you are multiplying. The exponent is how many times you multiply that number together. So check this one out, kind of a variation on a regular concept. If 2n equals 6, what does n squared, or n to the 2nd power, equal? So just like every other problem we have like this, remember, you gotta solve for n on the first equation. 2n really means 2 times what? Equals 6. So I'm going to solve for n. N is equal to 3. 2 times 3 equals 6, right? Once you have the answer for what n equals, plug that answer in for the other n to solve the problem. If we know that n is equal to 3, go and put a 3 in place of the n here. N squared, 3 squared. 3 times 3, right? Because 3 is the base. The exponent is 2, so I'm going to multiply 2 3's together, and that's going to give us 9, right? Not too tough so far if you remember the basics. So something a little bit different here. Here's some powers of 10. I wrote down the first 5 of them. I am not sure why 10 to the 0 power equals 1. You would have to be a lot better mathematician than I am, but true fact, 10 to the 0 power equals 1. That's the only one you're pretty much going to have to commit to memory. 10 to the 1st power equals 10, because if I just have 1 10, that would be all I'd have. 10 to the 2nd power, or 10 squared. 2 10's multiplied together equals 100. 10 to the 3rd power, or 10 cubed. 3 10's multiplied together equals 1,000. Or 10 to the 4th power, 4 10's multiplied together, that equals 10,000. Now, one handy dandy way of really keeping track of this, if you notice, the exponent will line up with how many zeros there would be. 10 to the 1st power, 10, there's 1 0. 10 to the 2nd power equals 100. There's 2 zeros in 100. 10 to the 3rd power equals 1,000. There's 3 zeros in 1,000. And 10 to the 4th power, well, there's 4 zeros in 10,000, right? All of the powers of 10 are on page 506 of your book, and you're going to see why we need that in 1 second here. Powers of 10 can also be used to show place value. Remember, 10 to the 0 power is your ones place. 10 to the 1st power is tens. 10 to the 2nd power is hundreds. 10 to the 3rd power is your 1,000 group. 10 to the 4th power is your 10,000 group. The trickiest one is, remember that the ones place is 10 to the 0 power. So Now that we know that, we can find out that we can use this to write expanded form. Remember, using expanded form, you use the parentheses, then the digit times the place value. Only we're going to use powers of 10. So it actually makes it a whole lot easier and quite a bit shorter when we actually have to go and write. So to start off with right now, let's get this number plugged in. It says write 4,500,000 in expanded form. So 4 million, that's going to give a 4 in the 1 millions place, a 5 in the 100,000s place, and then I have a whole bunch of zeros, right? And when I'm doing expanded form, I don't have to write anything for zeros, right? Nothing is the same as a zero. So digit times the place value. So let's start off right now. My first digit is a 4, and I'm going to put it in parentheses. 4 times 10 to the, what power is he sitting in? 10 to the 6, because there's 6 zeros in 1 million. Close out your parentheses, put in a plus sign, and let's start it all over again. Digit times the place value. 5 times, and I used to have to write 100,000. But 100,000 in powers of 10 is really 10 to the 5th power, right? So I'm going to go and write 10 and an exponent of 5 to show the 100,000s. Close out your parentheses, and all I have left is a bunch of zeros, and I don't have to go and write those down. Leaving nothing is the same as 0, right? And again, this is all on page 506 of your book. So check out this one. Write 120,005 in expanded form using powers of 10. So first of all, make sure we understand 120,000. You got a 1 in the 100,000s, 2 in the 10,000s, 0 in the 1,000s, 0 in the hundreds, 0 in the tens, and a 5 in the 1 spot, right? Always parenthesis, digit times place value. My first digit up is a 1. He's hanging out in the 100,000s place. 100,000 has 5 zeros, so this would be 1 times 10 to the 5th power. It's just an easier, shorter way so you don't get stuck having to write all those zeros. Close out your parenthesis. Put in a plus sign. Start a new parenthesis. Digit times place value. The next digit I have is the 2. He is hanging out in the 10,000s place, but I don't want to write a whole 10,000. I can use a power of 10. 10 to the 4th power, because in 10,000, there's 4 zeros, aren't there? So it's going to be 10 to the 4th power. Close out your parentheses again. I have a 0. I don't have to write anything. Another 0 and another 0. I have one last digit here. I have 5 in the ones place. So add your plus sign. Start a parenthesis. Digit times place value. My digit is 5. He's really 5 in the ones place, but the ones place is 10 to the 0 power, because there are 0 zeros in 1, isn't there? Something else we got to know, I think quite a few of us kind of have a handle on this according to mental math. They're also throwing square roots at us. And what a square root is one of 2 equal factors of a number. And The interesting part, if you look on a number chart, your square roots always line up in nice, neat diagonals. Because like 1 is the first square root, and is 1 times 1, so the square root of 1 is 1. 4 is the next perfect square because the two factors that multiply together that equal 4 is 2. So the square root of 4 would be 2. Square root of 9 is 3 because 3 times 3 equals 9. Square root of 16 is 4. 4 times 4 equals 16. The square root of 25 is 5. Square root of 36 would be 6. Two equal factors have to make up a square root. And square roots are written with a square root symbol. It kind of looks like a division box, but it has this funky little tail on the end of it, right? So if you see this, it's not saying divide 64. It's asking you, what is the square root of 64? What number times itself is going to equal 64? It has to be the same number. In this case, 8 times 8 is 64. So the square root of 64 is 8. So let's try practice on a few of these. This is asking us, what is the square root of 81? You got to think, what number times itself is 81? Well, that would be 9, right? 9 times 9 equals 81. Let's try one down here. What is the square root of 100? What number times itself equals 100? Well, that would be 10, because 10 times 10 equals 100. Let's try this one. They're going to throw them into some equations for us. The square root of 49 minus the square root of 16. I always recommend getting the answer first. Square root of 49. What number times itself equals 49? Well, that would be 7. 7 times 7 equals 49. Square root of 16. What number times itself equals 16? That would be 4, right? 4 times 4 equals 16. Once we have the answers, we're back down to about a second grade level. What is 7 minus 4? 7 minus 4, hey, that's going to give us 3. It's about that easy if you know how to work out the square roots. Let's try this one. Square root of 64 again. What number times itself is 64? That's 8. Compared to 3 to the second power. 3 to the second power, hey, that's 9. What is greater, 8 or 9? 9 is greater than 8. A lot of time kids will just see a way bigger number on the left-hand side and they'll automatically think they don't have to work it out. But it turns out 3 squared is greater than the square root of 64. Always work out the problem because the answer may surprise you. Here I have the square root of 9 plus 16 compared to the square root of 9 plus the square root of 16. But I assure you, they are not equal. Let's try this first one. 9 plus 16. Well, 9 plus 16 is 25. So this problem is essentially saying, what is the square root of 25? What number times itself is 25? Well, that answer is 5. Let's try this one. The square root of 9. What number times itself equals 9? 3, right? Plus the square root of 16. What's the square root of 16? What number times itself is 16? That answer should be 4, right? And if I go 3 plus 4, That answer is 7. Even though I have the same digits, these two problems are not equal. 5 is less than 7. All right, and just one extra little thing I want to tack on before we go, that there is a problem today asking you to display data in a horizontal bar graph. If you remember bar graphs, just use bars to indicate whatever level the data shows right now. So if you had a number like this, if you're trying to figure out Mexico, here's 5,000, here's 10,000. So what number is halfway in between 5,000 and 10,000? About 7,500, right? I'm going to imagine Japan's probably showing about 6,000. France here is probably showing about 2,500. The trick in this is always labeling your data points right now. This one uses an interval of 5,000. Maybe you won't need 5,000 each time on today's. Maybe it'll only be 1,000. Maybe it'll be 100. But you have to include your labels, and you want to label whatever data you are trying to chart, right? And give it a title. All important components for making a proper horizontal bar graph. And that, my friends, is the end. You are definitely going to want to use your book, especially for the powers of 10 on page 506. And maybe you would also want to look at that square root chart that is also in your book. Okay, you're definitely going to want to scratch a piece of paper for the Socrative quiz, and good luck.